Okay, so solving absolute value inequalities. Recall that the absolute value of a number is its distance from zero, and what that means is how many units it is on a number line from zero, regardless of positive or negative. So if the absolute value of -3 is 3, so is the absolute value of 3. Positive 3 is the absolute value is also 3 on the number line. We can see that -3 is 1, 2, 3 units from 0, as is positive 3, 1, 2, 3 units. I actually meant to do that in different colors. So this would be our negative. Okay, so when working with an inequality that contains an absolute value expression, it can be written as a compound inequality. So in example 1a, solving absolute value expressions involving less than. So the absolute value expression is less than some value. So this is when we're dealing with the less than symbol, we're working with a compound inequality that is going to be an AND statement instead of an OR. We'll see the OR statement next. So what I need to do here is isolate my absolute value. So if I subtract 3 from both sides, I'll get the, now let me switch to my pen, the absolute value of x is less than 9. So I want to solve for x. So I'm looking for solutions that are less than 9 units from 0. So that means that any value for x can be negative or positive, but less than 9 units away from 0 on either side. So I can write a compound inequality. So there's going to be a negative value and a positive value for x. So if I'm starting with on the left side of the number, left side of 0 on the negative side, so this value is going to be less than -9, or I'm sorry, greater than -9. So when we switch to a negative value, we're going to flip the sign. So it's going to be less than 9 units from 0. So x is going to be greater than -9. So 8.5, or -8.5, -7, -6 are all greater values than -9. And then we're going to have a positive value for x. So x is less than 9 units from 0 on the positive side. So when we graph that, this is greater than and less than. So -9 is not part of the solution, so I'm going to have an endpoint with an open circle at -9 and an endpoint with an open circle at +9, because it's not part of the solution either. So all the values of x that are less than -9 are a solution to this absolute inequality. So the variables on the left side, so it's the arrow is going to tell us which way to graph for this inequality. So we're going to go to the right to 0. So all the values in here satisfy this inequality up till 9, but not include -9, not including -9. And then this value here, to graph this, it's pointing to the left. So from our endpoint, we're graphing back to 0. Okay, and we can check that our solutions are correct by plugging in values to our original absolute inequality. So if I pick any value in this range, if I pick, say, -5, so we would write, so the original expression, the absolute value of x is +3 is less than 12. So if I plug in -5, the absolute value of -5 +3 is less than 12. Well, the absolute value of -5 is 5. So that becomes 5 plus 3 is less than 12. So 8 is less than 12. So that's a true statement. If I try a number on the positive side, so if I put in 7, so if I plug in 7 to my original expression here, my inequality, so the absolute value of 7 plus 3 is less than 12. So the absolute value of 7, of course, is 7 plus 3 is less than 12. 10 is indeed less than 12. So that tells us that our graph is correct and our compound inequality. So this is x is greater than -9 and x is less than -9. Okay, so in example 1b, given the absolute inequality of the absolute value of x plus 4 is less than or equal to 2, so we can rewrite this as a compound inequality. X plus 4 is less than or equal to 2, and x plus 4 is greater than or equal to -2, so we flip the sign when we're working with the negative value. So what this is saying is, what values for x that I plug in will make this absolute value, once we perform our addition inside here, will make it less than or equal to 2 units from 0, either negative or positive. So to isolate my variable, I subtract 4 from both sides, and I get x is less than or equal to -2. On this side, same thing, I'll subtract -4. I end up with, try and stay consistent with my colors, x is greater than or equal to -6. So equal to or less than -2. So -2 is part of my solution, so there'll be a closed circle endpoint here, and then greater than or equal to -6, so there'll be a closed circle endpoint there. So my variable's on the left, so my graphing is going to go to the left from -2, heading this way, and from my -6 endpoint, my graphing is going to go to the right, and the two meet. So your graph looks like that. And then if I plug in values to check my answer, -5 into my original inequality, absolute inequality, -5 replaces x, so -5 plus 4 will give me -1. The absolute value of -1 is, of course, 1, which is less than 2. So that's a true statement. I plug in -3. -3 plus 4 gives me +1. The absolute value of +1 is, of course, less than 2. So that is a true statement. So I know that my graph and my compound statement are correct. Okay, so moving on. So if we have an absolute value where we're working with the greater than sign, so the absolute value expression is greater than some value, we're going to end up with an OR statement. So here I want to first isolate my absolute value expression. So I'll add 20 to undo subtraction from both sides. And I'll end up with the absolute value of x is greater than 7. So the absolute value, so whatever value I plug in for x is going to be more than 7 units from 0. So it's going to be greater than 7 or less than -7. So going this way, these values are getting smaller than -7, and they're further away, so they're a greater distance than 7 units from 0. So we write our compound inequality. So we rewrite x. We're going to flip our sign. X is less than -7, or x is greater than +7. So -7 is not part of the solution, and +7 is not part of the solution. So you'll have open circles at 7, -7, and +7. Our arrow is pointing to the left, so we're going to graph negatives from our endpoint -7 to the left. So all values less than -7 are a solution, and this is pointing to the right for our +7. So we graph to the right. So all values greater than +7 satisfy our solution. If I check some of our solutions here to see if we're correct, if I plug in -9 for x, minus 20 is greater than 13. So the absolute value of negative 9 is 9 units away from 0. So it's 9 minus 20. It's greater than negative 13. So this gives me a negative 11 is greater than negative 13. So think about that. So negative 11 would be here. Negative 13 would be out. Oops. Would be, so negative 11, if I continue this, negative 11, negative 13 would be here. So this is larger than this value. So that's a true statement. Going the other way, if I plug in 8 for x, so the absolute value of 8 minus 20 is greater than negative 13. Absolute value of 8 is 8. So that gives me negative 12 is greater than negative 13. And of course, that's the same situation. So negative 12 would be here. So negative 12 is greater value than 13. So those are both true. So I can be certain that my graphing is correct and my compound inequality is also correct. If we look at one more example, the absolute value of x minus 8 plus 5 is greater than or equal to 11. So we're dealing with the absolute value expression is greater than, so we're going to have an OR statement again. So first I want to isolate my absolute value expression. So I'm going to subtract 5 from both sides. Oops. Would help if you could see that. So again, we have a greater than or equal to, so we're working with an OR statement. I want to isolate the absolute value expression first. So I end up with the absolute value of x minus 8 is greater than or equal to 6. And now I want to rewrite that as a compound statement where whatever value I plug in for x and then perform my subtraction will result in an absolute value of 6. So I can have a negative or positive value in here after I perform my operation that will result in 6 units from 0. So I rewrite it as a compound inequality, x minus 8 is going to be less than or equal to negative 6. Or, so I flipped the sign because I changed this to negative, or x minus 8 is greater than or equal to 6. Okay, so then I want to isolate my variable. So I'll add 8 to both sides here. And this will give me x is less than or equal to 2, because I have a negative 6 here. And add 8 to both sides here. Gives me x is greater than or equal to 14. So greater or less than or equal to 2, so that's 2 is part of the solution. So we'll have a closed circle at 2. 14 is also part of the solution, so a closed circle at 14. So my arrow is telling me to graph to the left of 2. So everything including 2 to the left of 2 is a solution, and the arrow is pointing to the right. My variable's on the left, so I can use that to indicate, to tell me which way to graph. So everything including 14 to the right is part of the solution. I plug in 0 into my original absolute inequality, so 0 minus 8. So if I put in 0, let's do it down here. So I plug in 0 for x, the absolute value of 0 minus 8 plus 5 is greater than or equal to 11. So this is going to result in the absolute value of negative 8 plus 5 is greater than 11. The absolute value of negative 8 is, of course, 8 plus 5. 13 is indeed greater than 11. And one more check. If I plug in 16 for x, so the absolute value of 16 minus 8 plus 5 is greater than 11, greater than or equal to. So 16 minus 8 will give me an absolute value of 8 plus 5 is greater than 11. And of course, 13 again is greater than 11. So I check, those are true statements, so my graph is correct, and my compound inequality is also correct.